Hello everyone. In today's video, we are going to talk about the concept of bucketing in Spark. What is bucket? How to decide on the number of bucket, and what is the concept of the working behind the bucket? We are going to see all these things in detail in this video. So basically, bucketing is dividing your data into a small chunks or different number of chunks, so that you can optimize your join operation, your group by operation, your filter operation in your program in your Spark application. Now, for an example, I have a order table, a very big order table, and corresponding product table, and this is also a very big table. So I'm going to perform an operation, a filter operation on this orders table. So df underscore orders dot filter, and I'm doing the filter on product ID, and I'm giving a random number 123. So this product ID is one of the key column of this order, and that is also the key column of the product table. So if your orders table is not partitioned or bucket or any kind of optimization technique you have not applied to the orders table previously, so what will happen? Your Spark application or your Spark will scan the full data of the orders table and search for the product ID equal to 123 and fetch the particular output. So there will be a full table scan, and just think of a orders table where you have a millions of record. So there will be a lot scan happening on the orders table, and it will consume a lot of CPU and also time. The solution to do is very simple. You can do the partitioning on the product ID, but there is a problem into that. The product ID is having a high cardinality, means the number of product ID, the unique product ID is huge. The reputation of the product ID is less. So whenever your key or particular column is having a high cardinality and it's a less repeated number, then multiple partition will be created. Very small chunks partition and large number of partition will be created, and which will give rise to the small file problem in the Spark. So you'd be knowing the issues which is caused by the small files or small chunks of file in the cluster. So that kind of issue will rise if you do the partition on a column which is having a very high cardinality. So the partition is not a solution for this. So bucketing is a solution for this, because in bucket we create a bucket. We create a logical layer, a logical bucket in which your orders rows will get into this bucket. Now, for example, I have a three bucket. I have created a three bucket for the orders table, bucket 0, 1, 2. And the product ID from the orders table will go into the hash function, and it will give the large number. But the large number, I mean, hash is a function. Hash function is a function, and the parameter is a product ID, and it gives some random number, a large number. But I have the product bucket number as 0, 1, 2. So in order to assign a particular bucket number to a particular record, for this output of this hash function is modulus by the number of bucket. So modulus by the number of bucket, it will give you the remainder, and that remainder will be 0, 1, 2. It will be less than 3. So every product ID will go undergo the hash key and hash function, and then it will be modulus by the 3, and it will give you the bucket number. So in this case, your data will be divided into different bucket. And when you apply the filter on that, when you write a query or when you write a data frame transformation as filter, so this ID, like the product ID 123, will again go into the hash key, hash function, the modulus by the 3, and a bucket number will be assigned, and then your Spark will search only on that bucket number for this product ID. So while doing the bucket, you don't have to do the full table scan. So whenever you create a bucket on the orders and then write the filter command, the Spark will automatically create the hash of this 123 and search for the bucket number. So you don't have to specify in the transformation that you have to go and search into the bucket rather than going into the full table scan. If the underlying table is already bucketed, so your Spark will automatically take that in care. Internally, it will create the hash of this product ID and goes into that particular bucket to search for that particular record. Fine. Now, how this bucketing is very helpful while doing the join. So in join, like if we join the orders table and the product table on the product ID, so what will happen? All the product ID, like if you have not applied any bucketing or partitioning, so while doing the join of orders table and product table on the product ID key, then all the similar or the same product ID of the orders table and the product table will get into the same executor, and in that process huge shuffling will take place. So whenever you do the join, then shuffle, sort and merge takes place. I'll write it here. So in joins, what happens? You have first shuffle happens, then sorting will happen, and then you have merge. So this process, so this shuffle will be CPU intensive process, and huge CPU will be consumed in this shuffle process. So while for removing the shuffle, this bucketing will be very helpful in the orders and the product key, product table. So when you apply the bucket for the orders table and the product table, so what will happen? Order, the same order ID will get into the same bucket. Product, same product ID, same order ID inside the product table will also get into the same bucket. So in a same bucket, or all the product ID, or the same, all the same product ID will get into the same bucket. One bucket can have multiple product ID, but all the same product ID will get into the same bucket. So in this case, the shuffling will be reduced a lot, and the joining process will be optimized to a very good extent. Now our biggest question is how to decide on the number of bucket. So there is a formula for deciding on the number of bucket. So first of all, this is the size of the data set. For example, your orders table has a size X, and then there is a optimum bucket size which has been decided by the Spark is 128 to 200 MB. Fine. Now you have to calculate the number of bucket. Number of optimum bucket will be total size of the data divided by the bucket size. So this is the bucket size. So if you consider 128 MB, so X by 128 MB. So this will give the optimum bucket number. Okay. Now how to consider, how to calculate the size of the data? That is very important. If you get the size of the data set, then you can get the number of bucket. You can decide on the number of bucket. The size of the bucket in size of the data in MB, you have a formula called N into V into M, and this is bytes. You can divide it by 1024 to the power 2, or into 1024 to get into the MB. Fine. Okay, let me remove this. Okay. Now what is N? N is your number of records. Your V is a number of variables. Number of variables means number of columns. And your M is the average width in byte of the variable. Bytes of the variable means column. So for this average number has been decided into documentation of the Spark. You can check what is the number for integer, or what is the number for particular data structure. So with this formula, you can calculate the size of the data set, and when you get the size of the data set, you can get the optimum number of bucket. So this was all about the bucket, in which scenario you have to calculate the bucket. One more thing I want to add, bucketing is also good for the sampling data. For example, you have a data of temperature of a particular region, or earthquake parameter of a particular region, or the vegetation agriculture parameter, or you have a data set of monsoon, or the rainfall parameter of in a data set. So to get the sampling of the data, the bucketing is a very good thing, because in a same bucket you can have a mixed kind of data, and to get a data from a particular bucket, your sampling data will be very good. So bucketing is very good for the join process. Bucketing is very good for the aggregate process, for the filter process, and also for the sampling process. But you have to keep in mind that cardinality of the columns should be high, because if you have the more unique number of that particular column, particular key, then only bucketing is very helpful. Otherwise you can go to the partitioning. If your uniqueness of the key is less, then you can go to the partition data. I hope you will be able to understand this concept. If you have any doubt, please ping me or mail me. I'll be ready to help you. Yeah, thank you.